Now we have seen how we express the forward interest rate as an expectation. Here we can take a look at how we can express a forward swap rate as an expectation. Okay, first of all, let's define the forward swap rate. So we have a ST as a forward swap rate. And this basically is a swap rate observed at the low t. Now we have a swap, a fixed for flow swap here. The swap will have a swap rate defined at big T naught. And there'll be payments at T1, T2, and all the way to Tn. Okay, so the swap has a maturity at big T, big N. Okay, and the swap will start at T0, big T naught. Now for that swap, obviously there's a realized rate here, but if we are at an earlier time, little t, there exists a forward swap rate. Now, how are we gonna determine this forward swap rate? Okay, here, that's assume the notional of the swap is just $1, just for simplicity. Now for that particular swap, you can just add $1. Let's say you add $1 at the end here for that payment, which you don't have. But suppose you have added to be received by the floating side. Now here, we have chosen to use the floating side also as the discount curve. Now I've written LIBOR here, and LIBOR is on its way to be replaced by another floating index rate. But whatever I wrote here for LIBOR, it works equally well for any other index rate, okay? That's using as a floating rate. In this case, both the floating rates used for the way to exchange payment and also used as a discount rate. Because of that, we know that if we have $1 here on the floating side, then we discount it. Then all the floating payment, and in between, we're receiving the interest rate on the dollar based on the floating rate. So for that particular contract, which is a contract for the floating side, that contract will have a value of $1 at this T dot here. So basically, if you were to receive $1 at the end, and in between of all those time period is the floating rate times that $1, that particular contract, if discounted by the floating rate, will have a value of $1 here. Now that value of $1 at big T naught is really this value here at the little t. So this really is the discount factor of $1 at big T naught at the little t here, okay? Now we have added $1 at the end here. We have to subtract that value out. Now the value of $1 at big Tn is this value at the little t. So at the little t, the floating side of the swap is basically this. Okay. Now the value of the floating side must equal to the value of the fixed side for swap. So what is the value of the fixed side? Now the value of the fixed side for swap is really that, if you were to have $1 paid here, 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 and here, right? That the present value of all those $1 paid in here, 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 in those time period will be this value here. Basically, is the discount value of this $1. And this part here is actually used for this rate, because this forward swap rate is expressed at as an annualized rate. So you need to multiply by the time periods here. You have to multiply by those time periods here so that it gives you the correct multiplier. So if an annualized rate is 12% and you're looking at a quarterly, so that'll be 0.25 times the annualized rate. 12% times 0.25 basically is divided by 4. So every period will be 3% times this $1. So you can express the value of the fixed side as this forward rate here multiplied by this annuity factor. Okay, so this is an annuity factor. Now, so we have an expression that as t times at, the forward swap rate times the annuity factor is equal to this difference between the two discount factor, or the price of two zero coupon bonds. Now with this, you can basically express that your forward rate, forward swap rate, as a ratio between this difference and the annuity. That's why it's called the annuity factor as the numerator asset. So the denominator is this annuity here. Now, since you can express something like this, anytime when you express something as a ratio, you can start to have this equivalent marketing approach. So essentially, you'll be able to call F as this difference here. So let's say you have a particular financial asset called F, which is essentially this. Then you have a financial asset called G, which is this annuity. So then you have a ratio between F divided by G, right? So here, your forward rate is expressed as this. So it's essentially the expected value at this when the little t is growing to big T naught. Okay, so the initial value here is really the expected value of the realized swap rate. So this, what you have here occurred at the big T naught, and it's a swap rate. It's basically the realized swap rate, which is a spot swap rate at big T naught. So you have successfully linked the forward swap rate as an expectation of the realized swap rate at a future time. Of course, the expectation is taken by using this numerator asset as the using this annuity as a numerator asset. So if you can use annuity as a numerator asset, you can express your forward swap rate as an expectation of the realized swap rate.